check who's running the show. Is anyone there? Okay. Well, I think I should just crack on and start. Any, just check. All good? Go? Thumbs up. Okay, we're on. Great to be back in person. My head is still in a spin from seeing real people. I'm not used to this at all. And I got my vaccine 1, got my vaccine 2, got my vaccine optimistically got my vaccine 3 on Monday, and have been wiped out since then. So I spent 2 days solid sleeping, and so if I feel a little bit out of sync, you'll know that I'm just getting back to normal. It's really, really wonderful to have us back together in person, and it's been 1 pandemic and 2 language versions for me. It's been a productive time. I'm actually really happy with how far we've been able to progress things in the world of Fsharp, and I'm just going to kind of take you on a gentle walk through what we've been doing since March 2020. And even one of the features we worked on, I really like this, it kind of brackets the whole thing for me. One of the features which I'll be talking about actually came directly from the very last Fsharp London meetup that we had in February 2020. And we got together, we talked about, someone gave a talk, Nick Blair gave a talk on what he called Applicatives. And I thought, yes, we should finally do the thing in the language to give proper support to this thing. And so, you know, there's a whole story here about how Fsharp 5 and Fsharp 6 have come about, and I just want to talk you through what we've been doing. It's a very informal talk, and I'll be giving lots of demos along the way. But the first part of the talk is actually a little bit different, which is we've also done some changes to how we talk about Fsharp. And and I thought I'd just kind of bring this up as a topic. You can talk about it amongst between us all afterwards and as we go. And they're an important set of changes that came through our work with the .NET Foundation and the Fsharp Software Foundation, and through some of the people at Microsoft as well, though by no means this is absolutely a collaboration with the community as well. And it's sort of a marketing exercise that a few of us did. The people in charge of .NET and the .NET Foundation and at Microsoft kind of said to us, look, you know, we understand Fsharp, it's absolutely fantastic, but do you have to make the functional thing about Fsharp so central to your messaging, the way you talk about Fsharp? Because we understand that for people who get functional programming, that makes sense. But you know, the value that you're bringing can be lost on other people who don't understand, who actually could be benefiting from what you've got here, but you're not reaching them with the messaging you're using. And so they asked us to kind of say, go right from back to the start about how you talk about Fsharp. And I sat down with Philip Carter, with Scott Hunter of Microsoft, with Nicholas Gustafsson, also Reed Copsey, Isaac Abraham, and others. And we started talking about who are we really aiming at, besides the kind of, you know, besides the people already using Fsharp. Who are we kind of talking about? And there's 2 really big target markets which are more indicators. They actually apply to pretty much every other programming language in the world, so in a sense we're after everyone. But we use these 2 groups as our kind of initial kind of starting point. We're after Python programmers, but we're not after all Python programmers, okay? The great thing about Python programmers is there's so many of them in the world. I only need to be able to address like 1% of them to have a really huge number of programmers, right? Okay, but Python programmers are absolutely hitting limitations, okay? They hit limitations with respect to typing, and they hit limitations with respect to performance in particular. If you write over 5,000 or 10,000 lines of Python code, you're really in trouble with regard to a lack of static typing. Okay, if very large chunks of Python code end up being moved across into C++ because of performance issues. Okay, and those of us programming in C# and F# in .NET know that that doesn't have to be the case. Okay, so Python programmers are hitting the limits. C# programmers are interesting. C# is an amazing language. It's progressed so far over the last from when I first engaged with it in C# 1.0. It's been on a long journey of its own to try to stop being what it originally was and become something else. Okay, and that is really really amazing. But there are C# programmers who frankly get a bit fed up with the whole object-oriented thing, and they look over towards the Python world and they think, I want that succinctness, you know? I want that kind of data orientation. I want that scripting. There's a whole lot of aspects which, although C# is working hard to get them into C#, they're not there in the sort of practical experience of using the language day to day. And so they think, well, actually, I just might leave the whole .NET ecosystem, right? And go, or go Python, or whatever else they think they'll do. And we think that doesn't have to be the case, that actually the .NET ecosystem can offer alternative views on programming, and that F# represents this really sweet spot between the worlds of sort of succinct programming and succinct data-oriented programming, and transition into fully statically, strongly typed programming as interoperable programming. So we did a marketing exercise where we think, okay, there are target markets. We want to write down all the technical features and qualities of F#. I haven't got the original of this. I've lost that, but. And then we kind of marked them up for relevance to the different target markets. Okay, is this relevant to C# programmers? Is this relevant to F# programmers? And we just sort of chose the top three, more or less. And it's something like this. It wasn't this one. And so we might, for instance, say, okay, here are these qualities: succinctness, robustness, performance, expressiveness, interoperable. And we started a group. We listed like 20, 30 of them. And we kind of bucketed them and so on. And yes, sometimes we found ourselves listing qualities, and then there are different features under those. So what supports succinctness in F#? Well, you have amazing type inference. It's expression-oriented. You have tuples. You have active. There are features that support a quality and experience. And robustness, okay, no nulls, functional abstraction, types, and so on. It lets you write robust code, reusable code, and then and so on. Typed code, generics without boxing, and so on, with performance. And what appeals to Python developers? Well, actually, the first group don't automatically appeal to it. They're kind of table stakes for Python developers. They say, well, of course you want programming to be like that. No one would want it to be any other way. So that's just the minimum that they need. But then there are these other things, like this robustness, which kind of really appeals. And then in C#, it's actually the opposite kind of. C# devs have a lot of great things with regard to robustness and performance, but they lack on that first kind of succinctness kind of thing. And so there's some things we didn't include in the top three, like we don't say, for instance, expressiveness or interoperability, or they're great qualities of F#, and you should always have them in mind in talking about F#. But limiting to three is a good thing. And so we chose these three themes: succinct, robust, and performant. And so when you see any core messaging around F#, I have to throw my glasses on and off. If you see any core messaging around F#, say in fsharp.org for the F# Software Foundation, F# empowers everyone to write succinct, robust, and performant code. That's the core message that we have, and you can kind of see it gives you the simplicity and succinctness like Python, with the correctness, robust, and performance beyond C# and Java. And then all the other things you want to talk about: open source, cross-platform, free, targets JavaScript, targets .NET, and what it can be used for. And that goes through the Microsoft messaging around F# in docs.microsoft.com. So if we go F#.net or something, then you'll see this is one of the landing pages. Open source language that makes it easy to write succinct, robust, and performant code. and mapping that through. Okay, so those are a change in how we talk about F#, and it's perhaps as important as what we've done in the technical work. And part of my change in thinking about F# was really influenced by this image that got tweeted around by Isaac Abraham. And it's based on somebody else's image and then extended out to the right. And it's reminding people that there's this eternal sweet spot of programming, which is functions and data. And it's not even plus types. The types are there. The use of types is there to support that sweet spot of functions and data. Okay, so everything is trying to keep you in that sweet spot and get as much of your programming as possible in the world of fairly simple functions and fairly simple data. That's always been what F# has been about. It's also what Python is great at. It just doesn't have a very good story with regard to types and performance and other things. Okay, you do need a whole bunch of other characteristics. But in the end, there's forever and ever and ever, there will be this sweet spot of programming, which is about functions and data. What happens with people is they start in this sweet spot and they love programming. They think it's amazing. And then they go off on this big object-oriented kind of thing, and they learn their design patterns and do objects everywhere, and they learn about abstraction and interfaces, you know, and I might, you know, planning for future change and everything like that. And then they find, you know, most of that, some of that is valuable. I'm not, it's an 80-20 thing all the way along. The sweet spot is 80%, and then there's this 20% where you need your object orientation and your object programming. And so you go through that, and and then you learn, oh, okay, you finally get back to this world of functions and data as being sort of the main focal point of your mind. And this other stuff you've learned still helps you, but you learn to use it appropriately. You learn to moderate it, okay? And so you're back to the world of functions and data, and then you discover functional programming, and you start going, oh my God, you start learning all about monads and applicatives. I'll even be talking about applicatives today. Category theory, effects, and everything. And a similar kind of thing kind of happens in a different dimension of functional programming, and then eventually you do get back to this world of functions and data. And that is the world where F# is focusing on. And it's one of the reasons why sometimes people come to F# and they think, wow, I don't have everything in, I can't, for instance, declare protected members in F#. I don't have everything I have in the object world. Well, there's a reason for that. We're trying to keep you in the sweet spot. Okay, we're trying to keep you in the sweet spot of functions and data. And they come, then they go learn the Haskell or something else, or Agda or something, and they learn. They've got all these amazing things to play with, and they say, I can't. Where are my toys? You know, and they throw a tantrum and say, you know, this isn't as big and powerful as my other functional language. So you know, but there's a reason for it, which is we keep you in the sweet spot. We keep you in the productive spot, and everything we are doing in F#5 and 6 and all the way through is about keeping you in that spot. Okay, so as part of the messaging change around F#, we also kind of tackle this question of sort of what is F# good at? What is it for? People ask that question. It's quite naturally, and these days we give a really simple answer to that, which is F#'s good for programming. Okay, okay, and we don't beat around the bush. We say it's good for absolutely everything. Okay. And we might qualify that. We might say it's good for, and this is some of the F# community, Dave Thomas and others, who just started answering questions on forums about you know, what is F# good for? And it's just like F#'s good for programming. So keep it simple. F#'s good for web programming. F#'s good for cloud programming, AI, ML, data science, whatever you like. We might talk about its qualities that we talked about before: robust, correct, and performant. So succinct, correct, and performant programming. But basically, F#'s good for programming. And in more recent material, since we're doing a full revamp, you know, we're just on the F# getting started kind of material. You just see the emphasis on this command line: .NET New, Lang, F#, .NET Build. You know, F# tools being part of everywhere. And we might talk about F# for the web backend. Using, say, Giraffe or some of the other options around for web backend, but it's a very similar story. Install the templates, .NET New Giraffe. Sorry, that should be .NET New Giraffe on this slide. and you get a fantastic hyper-functional server-side programming. And F# for the web front end using JavaScript, similar story, targeting F# to JavaScript. And this story with F# as a JavaScript language is really, really good. One of the sessions I got to do this year was to take the designer of Python, Guido van Rossum, and you might have seen at the .NET Conf days on F#. You can see the recording on the web. I recorded an online session with Guido where I teach him some F# code. And Guido's actually doing some client-server programming. He hasn't done much web programming in his life, you might be surprised to hear. And certainly not much client-side. And he's doing some F# on the client side and some F# on the server side. And he doesn't know which. It doesn't matter which side he's working on. He's just doing F# code on either side. All the tooling works really, really nicely. And so F# is also a JavaScript language. So, and you can do F# for the full stack with something like Safe or some other options. You can use .NET New Safe template, and there might be F# for data science and ML with this sort of getting started material using notebooks and a few packages. Okay, right. So that's just an update on how we talk about F#, how we think about it, and what it's. In a sense, there's been no change, because this is exactly what F# has been about all along. Okay, it's just being a little bit more explicit about what F# is and what it's trying to support and do. Okay, now I get to talk to you about F#5 and F#6. And we'll kind of change mode and go to just a walk through. I'm not going to go through everything in these laundry lists, but here's a laundry list from F#5. The ones in bold are the ones I will be talking about today. And then a year later, November, we did the same thing with F#6. Big long laundry list of things, and again, I'm not going to be able to go through every small feature. Probably, so if you want to find out about all the features, you can go to F#/FSLang design, which is where we do all the design, open design, F# community process for F#. You can come to the top of the repo here, and you can see all the RFCs from all the previous versions. You can come to F#5, check out all the details and follow through. These are great resources. They're technical documentation, but they also link through to the implementation. They also link through to the original suggestion. So you can see the full history of how we went about the design process and all the discussion. And so if you're interested in contributing to the F# language design, you can get involved, but these are a great resource for how we do the design process. Probably, since it's here and since I've got a fair amount of time, one of my favorite things about F#6 is that we put in this printf as a binary format. You can now use %b, but look at that RFC number. Isn't that good for a binary format edition? I was just saying, that was luck, pure luck, but it's how it came out. Okay, so F#6 has a whole lot of great things. Right, so let's talk about some of those. The first is we went in F#5, we went and did string interpolation. It's a wonderful feature. Okay, now I'll show you a little bit about what that actually means in practice. So I'm going to do some scripting here in F# Interactive here, programming. Okay, so a typical piece of string interpolation is this. It's where you get to use values in the middle, and so this string will format as I say 1 is 1 and 3.1414 is pi. There. Now, as many of you will know, F# already has a kind of form of string formatting where you could do this kind of thing. Okay, and you would not have this, and you would not have this, and you would put x and pi at the end here. It's C-style formatting strings. And one of the big problems with putting in string interpolation was what do we do about having two features for the same thing? And one is good in one way and one is good in another way. One gives you this sort of lovely kind of inline syntax for strings. The other one gives you strong typing. Okay, so if I, for instance, put %s in here, then I'll get a thing saying this is not a string, okay? And that's actually really valuable for pinning down your types. Okay, so one of the key things we did in the design process was to work out how to square the circle on this, how to triangulate these. And in fact, what that means is that in string interpolation, you can put these %d things to say, actually, this thing in here, whatever this expression is, x plus x plus x, okay, this has to be an integer. I'm going to constrain that to be an integer. And this one here, for instance, you can constrain to be a string, and you'll immediately get an error saying that thing there is not actually a string. And that's really important, because otherwise this expression in the middle here can be really anything, and it will just call toString on that expression, and it's very loosely typed. So string interpolation is a very sloppy feature, right, without this. Now, you don't have to use it, and of course, most of the time when you don't have to use the %, you can just use it as I had before. But the important thing from the design perspective is we got the best of both worlds between these features by combining allowing you to optionally use everything you've learned about %d formatting, % formatting, and use it in the context of string interpolation. You can also do that a little bit further. You could, if you know about using formatting using those things. So, for instance, you now want to start doing some formatting to get 2 decimal places down here. You can use that either using the .NET C# way, or you can do it using using these kind of placeholder kind of way. Now, there is actually for those in the technical details, there's some other technical details about how you can write, for instance, your own logging functions, which maybe post-process the string with the word log at the top up here, and then you can still use string interpolation even with that kind of setup along here. So just to run that example, and if I do that, then when it prints the number is result today, it says log the number is result today. And so you can kind of interleave a little bit. This is this kprintf thing. Interleave some extra printing along with your string output. Okay. So string interpolation. Let me just show you the RFC for string interpolation. Is here. It was the very first RFC ever created for Fsharp in 2014. And it went through 3 iterations, and each time 3 design iterations, I think 3 prototypes. And I'm just extremely happy with that. We took our time over this and eventually got to a point that combines these elements. And you can see the design principles we used, and read through them, and you can look through the detailed technical design and so on, all the way down. Okay. So why are we doing it? Improved readability, reduced errors, more succinct, less to learn. Okay? And you can see how that's playing into those original goals of Fsharp. String interpolation totally fits with the original design goals of Fsharp: succinct, robust, performant. So we managed to align with C#. You can take C# code and move it across and adjust it. But we also get this strong typing by unifying with Printf. And we allow it to be used with Printf and friends. Okay. Okay, so the next thing I'll call out in Fsharp 5 was that we added the ability to open the static content of types. Okay, so I'll just give a very short demo of what that means. So, for example, you can open type system.math, and that allows you just to use the min and max functions, for instance, directly, these overloaded functions here. And you'll see here that min is now overloaded between all the different things. And this is something quite different for F# and C#. In a way, C# broke one of its original design principles. One of the original design principles of C# was that if you had something overloaded, it would always be qualified in some way. So they broke that principle and allow you just to have these unqualified single identifier overloaded things. And we eventually decided in F# that there were enough important C# libraries using this that we were going to allow the same thing in F#. I have some qualms about adding this to F#. I'll talk about that more in a bit. You can use it on F# to define things. You can define your own type here like this. And you can do open type C, and then you can just, P here is now referring just to that static member P, okay? And something here is now referring to that something, okay. Okay, so why are we doing this? Because it does allow these sort of these DSLs, DSLs are often sort of focus a lot on succinctness and sort of dropping you into the domain without making you less aware that you're embedding the domain into the programming language. And so you get this ultra-synced mode of programming. So now these single word functions can actually also take named, optional, parameter array arguments. Okay, it does increase the kind of expressivity of what you can do in kind of DSLs, embedded DSLs. But that comes with a lot of downsides. And there's some particular DSLs, particularly those used for Apache Spark on Azure. So for the .NET and C# F# support for big data programming with Apache Spark. And they use these this open type extensively through their presentation. Be very, very cautious about using this in team situations, okay? Because it can obviously there are problems with this kind of feature. You open type, if you do open type from one DSL and open type on another DSL and into the same context, then the words and they're using the same words, the same overloads, and then things kind of start to go wrong, okay? The rule is that the second one wins. We don't allow overload sets to emerge from two things, but it could be that your DSLs kind of become less useful between these kind of conflicts that happen. And people are obviously going to have a harder time code reviewing this kind of thing if they haven't got strong tooling support to tell them where things are resolving to. So just be careful about using this and don't inflict it on yourself or your friends or your team without real thought about the consequences. Good F# programmers think about their team that they're working with and how they use the features of the language to make their team, the whole team, more productive. Okay, so in F#5 we finally did what we kind of should have done as soon as NuGet got created, which is to allow you to do #r NuGet in F# scripts. And so what does it look like? You do #r NuGet newtonsoft.json or give a specific version number. You can see, I'm actually not in an F# script in this file, but I'm in a .fs file, not a .fsx, but I've just put it in a comment at the top, so you can still send it interactive from this kind of thing. And you can see what happens. I've referenced two libraries here, Fsharp.data, Fsharp Core Fluent, and you can see it's gone through and processed those. And now I have access to those, fsharp.data. whatever. Okay, I've also referenced them in my project context over here. But if you're in a script, you can just happily use this kind of working, and it will work in both the developer tools and the IDE, before you even execute anything. And I may as well just show that. Open a new script. Script. There we go. Okay, so you can see I haven't actually executed anything from this particular script, and you immediately just get strong typing through to that set of packages that you've referenced. So people who are experienced with doing Python programming look at this feature and they say, this is the #1 feature for Python programmers. And it links back into what I said originally. What are Python programmers after? Okay, they're fine with succinctness. They don't want more succinctness. They've got that. They've got too much of that, probably, if anything, right? But they do want features like this, which lets you lock down the packages you're referencing, okay? Even better, you can combine this now with a global.json in your script directory, and the editing tools will take note of that global.json to say we're using a particular version of the .NET SDK, okay? And that means you can really lock down your scripts to just be completely trustworthy. You know what .NET framework they're running against, or you know what and what policy is applied to that, and you know exactly what packages are being used. You can also specify remote package sources. They have to be authenticated just via Azure, just via Active Directory or whatever integrated authentication you've got. We don't allow separately authenticated feeds from Fsharp scripts. You have to do those from project code. Okay, so that's a #I down there, just in case. And so the docs for all this are all online. It's a very simple feature, and it lets you get going with all sorts of great scripting programming just with a few lines. It's great. Okay. Okay, so on Fsharp 5, I now want to talk about a feature that's much more at the kind of programming language design end. The things I've talked about have been sort of practical, happy features. Nice. Everyone's happy with things like string interpolation. This next one is a bit of a different one because it looks so subtle. It's so strange. It's much more in the kind of expressivity kind of line for Fsharp, and in a way, it's outside those three themes, and it's not really aimed at C# or Python programmers, but I'm still really happy to have done this one in the Fsharp language design. And it extends this thing called Fsharp Computation Expressions, which is, anyone doing Fsharp will know what those are. That's where we have all these different things that kind of come from different programming languages, iterator methods, or query expressions, or comprehensions, or async sequences in, say, C# or other programming languages. And we kind of put them all into this one feature of Fsharp where you have some computational modality. You have a modality and then you have some code, okay? And that's called a computation expression in Fsharp. And you can do all sorts of amazing kind of things with this. If you take a look at what that means, C# say has 5 different features, all of these things down the left, and they sort of all become the same thing in Fsharp. They all just become a computation expression. I mean, you get different computation expressions, but they're one kind of language feature under the hood. And there's a whole history to how this came about. You can see some of my talks from during the year on the history of Fsharp. But the fact that we have this thing called computation expressions that lets you do so many different things and many, many more as well, just is one of this really unifying things about the Fsharp language design, and it does make the whole language design simpler end to end because we're not just adding more and more kind of complicated things down, which all work a bit differently. We kind of just add this one. We have this one feature, computation expressions. But there's something that computation expressions can't do. One of the things they can do in Fsharp, say 4, is this kind of let bang, this binding, this like await, or whatever kind of thing you're doing, let bang. And the point about computational expressions is some magic happens in between, as you say await, or you yield from a computation, or you're doing a coroutine or something like that. And so you have this sort of magic in between. And eventually it finishes with a return or a bunch of yields or something like that. But what it can't do is this what's called applicative binding, or this simultaneous sort of parallel kind of binding, where you kick off a whole bunch of things and I use the term very, very loosely, in parallel. It doesn't mean there's actually, I don't necessarily, in a way, there's two things going on. These things all kick off together, and then some magic happens to combine them together, and then they return. And it's as much the fact that this is a two-phase thing that makes this this interesting. Okay, that you want to have a static composition, which on the left here, and then a runtime over on the right. And so, for instance, this might be making your graph, and this might be running your graph. Okay, so from a language design point of view, all we're doing is allowing you to do and bang, let bang, and bang in these things. So that's the feature, let bang and bang, in computations. And when you use that, it maps to a thing called bind return or merge sources. And as I said, this relates directly to the last Fsharp London meetup before the pandemic. And it's often used to these things which in the Haskell world are called applicatives, and these sort of two-phase computations. And they separate composition from running. So you have a static composition and then a dynamic run. And for example, in the static phase, you might make a graph, and then before you run, you might pre-allocate a whole lot of buffers for that graph, and then you actually run your code. And there are lots of great examples of using this, say for validation or graphs of fixed size. I will show some examples. Let me just point you to some documentation on this. So I have a blog post you can search for Syme Applicatives, where we talk about the various styles for doing applicatives, and here you can see the let bang, and bang. And bang is the first part of the composition, and then the final part of the composition here. So one area where you might do this is to build a bunch of validators. Okay, so this is where you validate 5 different inputs, and then you're giving the result, the composition, the runtime for once all the inputs come in. So you're building your network of validators, and then at runtime you actually give the result of the composing of the validations. Okay, I will give a longer example of this now. And it is... So in this example, what we're doing is we're building a graph of nodes. Okay, so we have our node type here. Node is this abstract class node dirty here. And we're going to do a few things along the way, such as counting the number of nodes. And each node it's going to be an imperative graph. So we're going to have these nodes here, and they're going to link back to the nodes that they depend on. It's going to be a calculation graph, an explicit calculation graph. Okay, so let's go through and define our node type. And we're going to have a couple of different node types, a node of T here, and then a recalc node here that uses a function to recompute its value here. Okay, so sorry. Okay, and here is a constant node that is just always gives back the particular value x. And here's a input node that takes the value v, but where the input can change here when you set the value. And now, even though this is an imperative structure that uses mutation, you can still define a computation expression that allows you to build these things. So let's just do, just to take this out from, okay, so we define ourselves a node builder, and we define the input node, and then we define, a function to build input nodes, and then we define 3 input nodes here. And then we use our node builder to start composing these nodes together. So this function builds a new node, which takes in those 3 nodes, and then does a return of some computation like this, returning the sum of each of their nodes. And in this node here, we do it a different way, which is where we use sequential binding. So this is the difference between doing the simultaneous binding I showed and between doing the sequential binding, 1, 2, 3, let bang, let bang, let bang. Okay. And now we can, so 2 different ways of composing nodes. And now we can do a bit of work to see which one is more efficient, okay? So now if we compare what we've done here, okay, how many nodes did we create when doing the simultaneous one? And then what the test here is simply it creates the graph here. This n represents the final output node of the graph. And then it starts modifying the input nodes and gets an adjusted value. So it propagates the changes through the graph. And we see how many new nodes did we create along the way. And if you look at what we did with AndBang, we created 1 new node, okay, which was the composition node. And then we started modifying, and no new nodes got created, okay, because we had a static composition and 1 static output, and then we can just modify those outputs. But when you use monadic binding, the let bang, let bang, let bang, here, then you can see that we actually created 4,000 new nodes. And that's because when you modified those things with that chain of things, then when you modify the first one or the second one or the third one, you've got to rerun that chain endlessly. Okay, so even though it just looks so quite subtle, let bang, and bang versus let bang, let bang, let bang, there's actually a huge performance difference between those 2. And you might say to yourself, well, what happens if I only want the high performance one? Okay, well, what you do is in your computation expression builder, you can exclude certain kinds of binding. Okay, so you can comment out this binding here. You can comment out, comment out this one, bind to, and bind. And you only allow this this applicative binding, let bang, let bang, let bang, and bang, through bind return. And now you can see that you actually get an error here saying that this is not allowed. Okay, so in fact, this would this would mean that your team is only allowed to do static compositions of nodes, okay, in a way that won't actually create new nodes at what is effectively the runtime for the graph. Okay, and you can, if you like, as you saw in what I had before, you can define 2 kinds of builders. One is for node static, and one is for node dynamic, which allows, where the node dynamic allows extra kind of operations, extra kinds of kind of compositions, and then you can code review for users of node dynamic to make sure they're only being used, you're only getting dynamic creations of things as where you really need them. Okay. Okay. So. It's an interesting, subtle feature. It's definitely on, it used correctly. It absolutely simplifies a certain kind of composition. It's obviously a corner case in the language. It's rarely used, but it's still just really sweet and interesting form of composition to add to the language. Okay, at the other end of the spectrum, we removed a dot. Okay, and this is sort of the full spectrum of programming language design, from where you kind of think about these fancy forms of composition and their impact on performance and the like, and then you kind of think about what you actually need to do to your programming language, because it used to be the case that in order to do array or associative lookup in Fsharp, you had to do dot of index. Okay, and now as of Fsharp 6, you don't need to do that anymore, and you can just do expression of index. So why did we put in all the effort to make this change? Okay, well, we were just losing people for absolutely no reason, and I know this because one of my good friends who absolutely loves Fsharp, and he works in machine learning and vision research, he just said every time he gave a talk on Fsharp, he would just show some code, and people would ask, why do you need the dot? And then he would say, well, you just need the dot in Fsharp. That's how it works. We got it originally from OCaml. There are reasons for it in the design heritage of OCaml, but they aren't good reasons, okay? And he said people just turn off. People just say, well, I don't need to worry about that language, okay? I can forget about that, okay? And so what I like about this change that we made is it's actually making Fsharp more like it was always intended to be, okay? There was never any sufficiently good reason to be different. Yeah, as you saw with string interpolation and other things, we try not to differ from the industry norms. We try to, a lot of the Fsharp design was about making the language more like a normal industry programming language. And so this is in that theme, making Fsharp better by moving it towards it already was. Which I think if you compare that to what, say, C# is having to do, in a way, C# is always trying to become something that it wasn't originally. Okay, it starts off being this highly object-oriented language, and it adds these great features, but it's always sort of struggling against its initial starting point. But for me, this is just about making Fsharp better by moving it to what it already was intended to be. Okay, so in Fsharp 6, we also added task support. Fsharp already had async support, but it was a different type to tasks. And so we can see that in code like this. So here's some typical Fsharp async code, and this is async code that is interoperating with tasks. Okay. Okay, so if we didn't have this await task here, for example, then you'd get an error saying this thing is it producing a task, but we're expecting an async if you're going to bind to it here. So you had to put in this await task, and if you didn't put that thing at the end, you'd get an async. And let's say your job is to actually produce a task, you'd have to do start as task. So this is where you eliminate tasks, and this is where you introduce tasks. And Fsharp async is actually really, in some ways, it's better than task. But there's just a lot of task-based code around in the .NET world. And there are lots of good reasons just to make it simpler to write task directly. So nowadays you can, with Fsharp 6, it's built in that you can simply change this to task here. And you can remove this part here, and you can remove this part here. And you've got a thing that uses a task function, whether that's from some API or some code you've already written, and you're producing a task here. And otherwise, things are very, very much the same. But there are some differences you need to be aware. So a task is a single, mutable, sort of awaitable register. It has hot start, so the task starts immediately. So in Fsharp async, that's not the case. So in Fsharp async, you'd have to let's say we did this, then you have to start that async directly. So you're in a separate phase. So you do use function 2, 3, you do async dot start. Sorry, for instance, run synchronously. Okay, so but tasks aren't like that. When you have task code, the code starts running immediately. So as soon as you execute some function, this task starts running until its first await point. So tasks are hot start. They also don't do cancellation checks along the way, and they don't propagate a cancellation token automatically. One of the really nice things about F# async code is it propagates that cancellation token all the way through. You can just make life much simpler. That's not the case with tasks. You have to explicitly do that, and they also don't support this thing with tail calls. You have to be a little bit careful about recursive tasks. And that's all got to do with the limitations of .NET tasks, but nevertheless, there's still an awful lot of cases where you just want to write tasks directly, and so it's great to have that support built in for the language. It's also debugging can be a lot better than async, and the performance can also be better than F# async for when that matters. Okay. So just to conclude with a few more points we added. So we did some deprecation. We actually started deprecating quite a lot of things. For instance, there was this very old thing called the ML Compatibility Mode right back from F# 1.0. That's all been deprecated and limited to F# 5.0 and before. There are also these things called reference cells, which use these operators bang and colon equals. Okay, so just to give a sample of that. Let me just undo here a bit. Fine. Okay, so I draw ref cell deprecation at 5. Okay, so you now get a deprecation here saying the use of this operator from the F# library is deprecated. Please use a more explicit form. Okay, and you used to be able to do sort of bang R like that. And it says, please don't do that. Please use .value now. And this kind of programming is actually almost never needed in F#. And in any case, so because these days you can nearly always just do let mutable R equal this, like this, and then you just use R directly like that. So we decided to deprecate that through a very soft deprecation, just that informational warning that comes up to saying, please don't do this. That's very much a very major reason is because of that bang R that we had is just obviously so confusing to people coming from Python and C#, and we just can't have that in the language in the long term. We have to get rid of that kind of confusion for people coming from that that world. And there are cases where this, where you see this kind of code, this kind of thing, false and finished true or something, sort of while not bang finished do ... that sort of thing. Of course, people don't, people coming from the C# world will see this. I mean, we just can't have this in the language. Anyway, it's gone. So we just delete all of that. Okay, so that's soft. So don't use those operators, and you'll get soft deprecation messages. F# compiler service now fully multi-threaded, no reactor queue. The IDEs are way more responsive. Visual Studio 2022 is now 64-bit. Lots of other major performance improvements in their compiler, the IDE, the tooling. They're in the announcement blogs. Take a look at those. One thing I am going to show next is to do with, on the tooling side, is to do with pipeline debugging. And in this, since I'm just running out of time, I will just show that here. And I'm going to press F5 to see. Hopefully it builds okay. Yeah. Okay. So now in F# 6, you can set breakpoints on pipeline stages like this. So any of these down the way. And if you take a careful look down the bottom left, you can see what the input to the pipeline is. And this is actually an example which is doing some screen scraping from a Wikipedia site to do with the British TV show Doctor Who. And it's getting the episode list to Doctor Who and who were the directors. You can see the Daleks here. And you can see that was our original input. And then we did some filtering of that. Actually, nothing got filtered out. You can see that there's nothing being filtered, 261. And then you can see that we only searched for the Dalek episodes here. And they had a full 218. No, we're grouping by whether the thing contains Daleks or not. And then, oh no, that's the result of the grouping. This is between 193 episodes didn't contain Daleks, and 25 episodes did contain Daleks in the first few years of Doctor Who. Okay, so you can see pipeline debugging. This is one of my favorite features of F# 6. I use it all the time. Just stepping through the compiler, it's just so much more enjoyable. It's one of the first times we've actually done a debugging feature that is specifically related to something strongly associated with F#, this pipelining thing. So really very happy with how that one works. There's also some work on improving how we show shadowing values in the debugger. List and array expressions have had like a 4-time performance improvement in how we compile those constructs. We no longer do them in the link kind of way, but just generate really fast generator code for them. And you can take a look at those. We've also, from the F# community, had this improved map and set performance by Viktor Babikov. And just that was in F# 5, and just massive improvements to the performance of the core map and set data structures. So we've also done some doc improvements. There's loads of, almost all the functions in Fsharp.core come with proper examples now. And you can also turn on some XML Dock Checking in your projects. If you go through and put this on, warn on 3390, you do have to turn this on explicitly for various compat reasons. So warn on 3390, and you come to your error list. You'll see here, for example, that I've mistyped a tag on my XML docs. So you'll get XML Dock Checking in the IDE and it'll check, for instance, that you've given a documentation for each parameter in your functions and so on. Okay. So I do want to say just what an incredibly collaborative effort this has been. Here's the thanks and acknowledgements for F# 6. So many people have contributed to this from across the F# community. They're listed out. 2 people call out Nino Flores and Hadrian Tang here. Hadrian is a 19-year-old student from Hong Kong University. He contributed about 4 or 5 of the features in F# 6. So isn't it just fantastic to see people coming into the .NET community with, who are with that kind of energy right at the start of their careers as well. But loads of people have contributed. Okay, and that's it. Thanks very much. I don't know if we're taking questions or not in the talks. I guess I'm kind of out of time. So maybe we will take the questions outside. Unless we'll take one question. Anybody got a question? I can barely see you all. Sorry, I can't even see. Anyway, we'll take questions outside. Just here. Thanks.